add this.
Okay, and so welcome guys, right, to the Ansible meetup, right? We have been trying to do cover automation mesh for quite a while, right, since it came out. But now as the technology matures slightly more, right, we wanted to do a sharing session on automation mesh as well as show what are the features that are surrounding it and also how does it look like from the current release, right, from Ansible controller itself. Um, so we have today Vinod, right, which is our one of the regional specialists, right, senior architect that is from our solution architect team, and he's helping us today cover the bits and pieces that are surrounding automation mesh, as well as help us as well answer any other questions that you may have, right? Fret not, Anthony and myself are also here to answer your questions. If you have any questions, please feel free to put in the chat, or as you know, this is a meetup, right? So feel free to unmute yourself as well and stop us if you want to ask any questions. So with that, I hand over my time to right, to go through the session itself.
Hey, thanks, Eric. Thanks. So let me go on. Okay, so good morning, everyone. So today we will kind of look at automation mesh, what it is, and what problems does it solve, right? We will see how we install it, configure, and use it along with a demo. And at the end, we will also look at some of the common deployment scenarios of automation mesh as well, right? So that's the kind of agenda for us today. Uh, Please feel free to ask questions, right, as Derek mentioned. And so let's start with why automation mesh. Okay. So to understand that, let's look at the pre-mesh environment, right, where we had Ansible Tower and isolated nodes. Now, in that architecture, we had both the control and the execution on a single environment, right? In a way, you can say it was tightly coupled. The architecture, if you remember that the architecture allowed us to expand and scale, right? But it had its own challenges. Like, for example, the scaling needed to happen as a whole unit. So if you want to scale, you have to scale the node, which included both the controller and the execution plane, right, together. So you have to do it as a whole unit. Now, because it was combined, so the capacity was shared, right? So if you want to track and manage capacity for execution plane separately, it becomes very complex. And in in case if you want to scale, right, if you want to change the capacity, so while down the line, it required some downtime as well for us to do it because everything was actually in same one environment. And we also had isolated nodes, right, to support different deployment topologies, segmented networks, etc. While it helped in various ways, it also had some limitations. Like if you remember the way actually isolated nodes work, it used the SSH and a one-way communication from the cluster, right? So this often means that we required jump hosts and proxies. You need to configure them, etc. Right? And it was also sensitive to latency. So we had these kind of challenges we wanted to address. So to overcome these, we leveraged some of the industry best practices, right? So one, we have decoupled the control plane and the execution plane, right? Instead of having it in one single node, we kind of decouple them. Second, we started leveraging the cloud native containerized environments. And I hope you would have already heard about the execution environments, right? And the containers, how we use them. Right? So, so these are the kind of key kind of practices we are kind of used to kind of create our Ansible Automation Platform 2.0 architecture. Now, so what is automation mesh and how does it relate to this? So in simpler terms, automation mesh provides a flexible architecture to scale the execution capacity reliably across different network topologies. It basically kind of establishes a secured bidirectional peer-to-peer connection between the nodes, right? Creating a distributed overlay network, right? To use the distribution of automation execution, right? So basically we have the controller, we have the place where we execute the automation. So everything actually is connected like a mesh over here. Now, this helps us in many ways. One, because actually we kind of segregating this kind of control and execution plane, and we are kind of creating a mesh overlay kind of a peer-to-peer network, we can deliver and run the automation closer to the endpoints, whether is at the edge or at different DCs or at different VPCs in different clouds, right? So we can actually kind of do that while having a centralized management. Okay, so centralized management, but the execution can happen at different places. It also helps us to provide dynamic cluster capacity. So by scaling, actually what I mean by that is scaling the execution capacity horizontally without any downtime. So say for example, in this scenario, I have 3 execution nodes today. Tomorrow, my kind of I'm expanding and scaling, so I need additional execution capacity. So I can just go and add another node, execution node, and I can actually connect this to my automation mesh directly. Okay, so I can scale horizontally. Now we can also scale reliably by using this redundant mesh routes, right? And multiple hop routes. So what I mean by this is that, so let's take an example here. So in this scenario, I have my controller and this actually execution node. So I have the connectivity here. So let's say, for example, if this connectivity goes down, okay? Now, to reach this execution nodes, now the automation controller can go via alternate routes, right? So basically in this scenario, it can go via this and it can reach this guy, or it can go via this as well. So you have some redundant actually routes we can use so we can reliably scale. I'll show one of these scenario in the demo as well. And all these communications between these nodes are happening using mutual TLS, authentication and encryption, right? Providing us better security. So in summary, automation mesh helps us to scale better and support various deployment topologies. Okay. Now, what has changed and what hasn't changed in the Ansible Automation Platform 2? So which just wanted to highlight some key changes. So 2 key changes which you need to be aware of. One, isolated nodes is discontinued. So instead of isolated nodes, we will use automation mesh. And second, the bubble wrap process isolation we had earlier in the tower is replaced by execution environments. Okay, so these 2 are the key changes which you need to be aware of. Now, what has not changed is that the instances groups, and the container groups which we had earlier, it will remain the same, and we will use this instances group to use the mesh as well. So I'll show it in the demo. Okay, so the change you need to be aware of. Now let's look at how we can configure and set up automation mesh. Okay, we saw what it is, but let's see how we can install, configure, and set up it. So before we see that, let's understand some key concepts. So first thing is, let's understand what's control plane and execution plane, and what are the different node types in those planes. So first, control plane. Control plane, as the name implies, is where the controller runs, right? And there are 2 node types in the control plane. One is the control type of control, and the other one is called hybrid. So if the node is of type control, that means it's purely used for control functions, right? That means no automation execution will happen on these nodes, no workloads, nothing will happen. Even though the management jobs can run, but no automation playbook or workload will run on these nodes. Okay, that's the control node, so plain control. Then we also have hybrid node type. So in this node type, the control node can actually perform both the control function as well as the automation execution, right? So it can be used for both as well. So you can define what type of node you want in the while we install it. So that's the control plane. Now, in the execution plane, so we also have two node types. So one is the execution node, so which executes the automation on behalf of the controller nodes, right? So it replaces the isolated nodes, but fulfills basically the same function, like running the automation closer to the endpoints. The other type is a hop node. So these nodes are like akin to jump force, right? It will route the traffic from the controller towards the execution nodes, but it does not execute any automation. So this is just like just a kind of a pass through. So it passes through the traffic. It doesn't execute anything. Okay. So we have control plane, two types of nodes, two node types. One is a control and the hybrid, and in the execution place we have two types: execution node and the hop node. Okay. Now, how we install automation mesh and configure? So it's through our installer, right? Installer inventory. So in the inventory, while we kind of install, we define the control plane nodes using automation controller section in the automation controller section, and the execution nodes are the execution plane nodes under the execution node section, right? Then once we define this nodes, like both the control plane and the execution plane nodes, then we kind of create this peering connections using the variable called peers. So we tell how to have this peering connections. Okay. Um, by default, all the communications, all these things actually happens via TCP port 27199. So one thing you need to keep in mind that for the automation mesh to work, so you need to have a TCP port open, right? So that the connectivity and the mesh connection can happen. So 27199 is the default port. Of course, you can change it in the inventory. Okay. Now, once this particular thing is set up, we will use instance groups to group our execution nodes and use it for specific automation. Like, for example, covering an automation for specific inventory, right? A remote DC or a cloud actually automation, right? Or running specific templates, etc. Okay, so I'll kind of show you in a demo as well, so you can actually really see what it is. Now, one actually kind of I define this in the installer inventory. I can also view and validate it, right, before installing itself. So the installer actually can generate what we call as a graph.vis.file from the inventory to show you the topology, right? How this all the peering and the mesh connection will look like for you. And also the installer also runs some validation while during the installation or before the installation. So it checks all the connectivity and everything so that it gives you any issues before in hand as well. Okay, so let me. So let's take an example and see how it looks like, right? So I'm just going to take the demo setup. So this is my demo setup today. So in the control plane, I have two controllers. So I have controller 1 and controller 2. Okay, so controller 1 and controller 2. And from the execution plane, I have one hop node and one execution node. Okay, it's a very simple topology just to explain the concepts. So I have two controllers, I have one hop node and one execution node. Okay, and the peering happens actually between these nodes. So how do I define this topology in the inventory? Okay, so let me kind of quickly show that in the inventory file itself so that it's easier for you to understand. Let me jump in. Okay, so this is my inventory, okay, of my demo setup itself. So you can see here. Okay, so in the inventory, so as I mentioned, the control plane nodes are defined under the automation controller here. So I have two nodes here, controller 1 and the controller 2. Okay, and these two nodes are of node type of hybrid. So basically, it's going to run control function as well as it can be used for automation execution. So as you see here, by default, if you don't give this node type, it is going to be kind of treated as hybrid. Okay, so the default is hybrid for us, but I have defined it here explicitly. Now, on the execution plane, which is defined by under the execution nodes, I have two nodes, like as I showed in the picture earlier. So one is the execution node one, and the other one is actually my hop node here. Now this hop node is of type hop, so as you can define here. And the default here is for the execution nodes, the default is execution, right? So if I don't define this node type, it's going to assume that it is going to be a execution node. So here I'm defining it's a node top as hop. Now, once I define the nodes, then I'm going to define the peering connection. So how do I define? I define using the variable peers. So in the automation controller variables, I'm saying peers equal to this hop node. So what this means is I'm saying all the controller nodes are going to be peer with the hop node. Okay, so that's the first thing I'm saying. Okay, if you see this, let me see if I can bring this up. Okay, so just to show you this as well. So here, the peering we are talking about is this connection, right? So basically, so this part, so this connections we are talking about. Okay, now let's look at the other peering connection. So here in the execution node, I'm saying the hop node is paired with my execution node. So this is what I'm just defining it. So basically this part of it. So this actually connection which I'm talking about. Okay, so that's how we define the peering. Now, one thing to note here is that which I have not defined explicitly, is the peering connection between the controllers. So by default, all the controllers will peer between themselves, right? So I don't have to explicitly define the peering connection, but by default, it will peer between all the controller nodes. Okay. Okay. So that's kind of defining the peering connection. Now, I was also talking about the port, right? So if I go in here, let me see. Okay, so my listener port here I've defined as 27199. So that's a default port. So I'm just using it here. But of course, you can define it, define port. And I have defined this as an actually in all where. That means everywhere actually in all the nodes, it's going to use 2719. But you can also define per node as well. So if you want to define it differently for certain type of environment, you can define it different port as well accordingly. Okay. So that's how I define my topology, what I showed you earlier in the inventory file. Okay. Now, once I kind of define this in my inventory, so the next thing is I can actually go and visualize it, right? Before even I install it, I can actually go and visualize it. So how do I do that? So I kind of use the setup again, and I can actually use the tag generate.file. So basically what it does is it creates a mesh topology dot file. So this is a graphics.file. It's a text file. It creates this, and which actually defines the entire topology in a text format, like graphics format. I can also give the extra variable generate.file to kind of store that data into a different file if I need it as well. Okay, so this actually gets me the textual graphics.file. But if I want to see that actually visualize it, that text file, I can actually use multiple ways. So one is using the dot command line itself. So I can just use dot, and then actually I can generate a JPEG file so I can view it. Or you can actually use online graphics visualization environments. So here actually is one. I can actually copy paste that text file from which has been generated and paste it, and I can view that as well. Or alternatively, I can actually also use some of the VS Code plugins. So if you are using VS Code, so you can actually use graphics plugins to view that as well. Okay, so this how it looks like. So first is generate the dot file. So it shows you the text content on it, and the dot command will actually generate the picture that which you see here on the right? So it actually generates it. So let's quickly see this in our environment. So to do that, let me jump into my controller. So this is my controller one. This is where it actually I have my all my inventory, etc. Okay, so if I see this, so I have my inventory, etc. here. Okay, so here I'm gonna kind of run my setup. So basically, I would say setup.sh tag generate.file. So I'm not going to give a different file name. So it's going to generate it as mesh-topology.file. Okay, so it's going to run, take the inventory, check everything, and then it's going to generate a file. So now if you go here and see, so there is a message. So it says Ansible mesh topology graph created. So it's actually stored in mesh topology.file. And to render your graph.graph, you could run this. So it gives you the command to run it as well. So I can just use it to generate the topology.jpg as well. Okay, let's look at this file. So I'm going to Visual Studio Code, VS Code here. Because it's connected to my controllers, I can view the same thing here. So if I go here, so the one which generated was the mesh topology.file. So this is just a text file. So you can see this actually defined on it. Now I can actually visualize. So if the topology graph topology.jpg, which got generated here. So this shows you the the visualization of this particular dot file. So I have two controllers here. I have one hop node and one execution node, as we saw. And then you can see this, there is a pairing going between the control nodes as well, right? Which I was saying that it's implicit. Okay, so that's one way of actually looking at it. The second way is I can copy this stuff. So if I take this mesh topology.file, I go to my graphics online. Okay, it's already there. So I copy paste it here and it generates me the same kind of a picture as well. So that's another way of actually visualizing it. Okay. And the third way is using the VS Code itself. So in my case, actually, I'm gonna kind of do, okay. Okay. So let me close this. Yeah. So it generates the same thing. So you can actually view it in multiple ways. Okay. So this is actually showing you how it is so that you can view it before you can start installing itself. Okay, let's jump back right in. Okay, so once you install it, right? So once you install using the inventory file, so what happens and how does it look like in the controller? So in the controller, there will be kind of instance groups which will be created. So by default, there will be a kind of two instance groups. One is called default and one is called control plane. So the default instance group will have all the execution nodes. In this scenario, in my case, I have one execution node and two of my control nodes as a hybrid node. So basically, three nodes will be part of the default instance group. And this is the group which will be used if you don't define any instance group for your automation job. It is going to use this default instance group. And it will also create another instance group called control plane. So this will kind of hold all the control plane nodes on it. So let's quickly look at that in our environment. So I'm going to my automation controller. So this is on my controller one. So if I go to my instance groups, so there is called default group and the control plane group. So the default group, if I go in and look at my instances, so it's got like controller one, controller two, and then it has got also my execution node one. So all execution nodes under this default group. And I also have control plane. So this was going to have only the control plane nodes here. Okay. And so this is what default it gets created. And you can also create anything after installation, you can create different instance groups as well. So in my case, I have one instance group I have created called private execution nodes here. So basically, so this one. Okay. And if I kind of look into that, so I have instances. So I have one execution node under it. Okay, so one thing here to note is that this is a group, right? So I can have many execution nodes in the specific group as well. So, but in the demo environment, I just have one on it. Okay, so that's basically how the nodes will kind of appear in the, or how it can be used as well in the controller. So let's jump right back in. Okay. Okay, so far so good. So we saw actually how we can actually set it up and how actually the instant groups will look like. Now, we can, apart from this instance group, right, what I was talking about, we can also leverage Kubernetes and OpenShift to execute our automation. Like, no need to have execution node itself separately, but we can also use Kubernetes and OpenShift. Again, this is done via container groups, so there's nothing new, but I just wanted to highlight here is that it's the same as the previous, right? So while we have automation mesh, we can also have this, right? We can also execute and using Kubernetes or OpenShift as well. So for those who have not heard of this container group type, so container groups are type of instance groups. Basically, it specifies a configuration for provisioning a pod in your Kubernetes or OpenShift cluster, right, where the job will run. So these pods are provisioned on demand and only kind of exists during the playbook run itself. So I'll show this actually in the demo at the end, that how it works as well. Again, it's nothing new. It's actually same from the previous versions as well. Okay, so now at this point, I wanted to kind of go into the demo and probably show you how the automation mesh looks like and how we can run it and etc. And at the end, we will also go through the deployment patterns, right? So let me stop over here before we get into more into the kind of demo. Any specific questions you guys have? Any other thoughts you have?
I think some of them placed in chat. I think myself and Anthony did answer most of them.
Okay.
Um, yeah.
Mm. Okay.
There's
Mhm.
no questions. Then I think we can continue first. Yeah.
Okay, great. Okay,
Thanks.
so thanks, Derek, and thanks, Anthony. So let's look at this. So this is the kind of a demo setup I've already shown you earlier. So on the demo use cases, so first we saw the installation part of it. So we saw the inventory setup, we saw the dot files, graphics, visualization, etc. Now we will look at the running and testing part of it, right? So how do we kind of, once this is installed, okay, how do we check this automation mesh and how do we use it to run our jobs? So that's what we will do that in the next section. Okay, so let's quickly jump into our demo environment. Okay, so I think I didn't mention it earlier. So this particular automation mesh is based on the upstream receptor, right, project. So if we, once all the things are set up, if you want to view the status, the runtime, actually the status of the automation mesh, you can use the command receptor CTL. Okay, so I'm on the controller one. So I can actually kind of do receptor CTL, and then I can have to give the socket. So this is a default socket, and then I give a status. So this is going to give me the status of the mesh from the point of view of controller one. Okay, so this is giving me from the point of view of controller one. So let me kind of explain this, whatever, or a lot of text actually it has actually put in. So let me kind of explain this. So first, okay, I have the node. Basically, it just explains me what's this particular node is. So this is actually my controller one. So it tells me that. And then I have a section called connection. So this connection actually shows us what are the direct connections this particular node has. So in this case, I have two connections. So one to the hop node and the other one to the controller. Okay, so basically I have two connections, direct connections. Okay, now there is this route section here at the bottom. Okay, so this section tells you how the connectivity or the reachability works. So basically the route itself. So if you look at actually here in our environment, the execution node one is reachable via the hop node. So you can see it actually, it knows that to reach the execution node, because there is no direct connectivity, so it is going to reach it via the hop node. While if you look at actually the other controller two here, which is defined here, controller two, it will say via controller two. That means it's directly connected, right? As we saw earlier, which shows. Similarly, for the hop node, it is directly connected. Okay, so that's shows you the route as well. Then this no node section. So this actually section tells you the entire actually automation mesh kind of details. So it tells what are the known nodes for each of the nodes in the mesh. So let's take an example in the scenario that let's, for example, let's look at the hop node. Okay, so the hop node here actually knows the controller one, which is it's connected to controller one, controller two, and the execution node. So you will see that actually this is, even though actually this control one is not directly connected, but it knows that the hop node actually has direct connection from to controller one, controller two, and execution node one. Similarly, if you can see this for the execution node, we will have execution node will be having only one connection, which is going to be to the hop node. Okay, so this actually tells you the current status, right? So from if you have any trouble looking at what if there is some connectivity which is not working, etc., so you can actually come and look at this status and you can see clearly what the mesh is actually looking at, right? So you can actually view that. So this is from a controller node point of view. So let's quickly look at from an execution node point of view. So I'm in the execution node. So if I do the same receptor ctl status command, so this is actually from the node, this execution node one. And here you can see this, it's only one connection. So basically it's one direct connection I have, which is with my hop node. Okay, so and from my route perspective, if you look at it, so I'm going to reach, so basically the controller one via hop node. Similarly for the controller two, I'm going to reach it via hop node. So this tells you that connectivity back, so it knows how to reach the controllers here. Of course, hop node is actually hop node because it's just directly connected. So you can see this as well. So from each of this node point of view, you can actually view the status and you can see how the connectivity looks like. Okay, so once you kind of see this, this actually gives you a view of how this entire mesh actually things is set up. Now let's start actually using this in the mesh. So let's go back to in this now. Let's go back to our controller. So as I kind of mentioned earlier, so the way kind of we use it is using instance group. So in this instance group, I have defined so private execution nodes. I have defined one. This is my execution node one. So this particular node is used for my all my, say for example, remote DC kind of automation execution. So how do I kind of map this? So this particular execution by instance group can be mapped to either an inventory, or it can be kind of mapped to a template, or it can be mapped to a project, right? I mean, organization. So in my scenario, I'm going to kind of map it to my inventory. So I have an inventory called the remote DC1 inventory. Okay, so this inventory is actually connected to, so it's going to use the instance group of private execution node. So the one which I just showed you, so our EE node on it. Okay, and for any of the automation which is run for this inventory, this is going to use this one. Okay, now I have okay, templates. If I go to my templates, so I have a template which is configuring a web server. It's a simple template. So this one actually is actually using this remote DC1 inventory. So in turn, this is going to use this execution is going to happen on the private execution node instance group. Okay, so let's look at this part, like how does it look like? So I'm going to launch this one. So before I show you this, let me put this side by side. Let me go to my, okay. Okay, I'm on my execution node. So let me go to, okay. So what I'm going to do is that in my execution node, okay, so I'm actually watching my Podman peer. So basically, if there is any container which gets created, so it's going to show me. Okay, so I'm watching this. So if I click on next over here and launch it, so basically it installs a web server. So as soon as you see this, actually, there is a container which got created here. Ansible runner, it's running it in my execution node. And as soon as actually the job gets completed, of course the pod actually the container goes away, and you can actually view the logs immediately on the controller. So because that's one of the things, right? So as soon as actually this thing actually completes, you can immediately view the log files. In the isolated nodes, it took some time for it to get that as well. So here you can see this, it's changed this, so it actually kind of completed. Okay, so this basically how we can use the automation mesh and the execution nodes instance groups. Okay, now let me kind of show you one more thing. So if I go to my template, okay, let me make it big. So this was actually the one which I kind of used on this one. Okay. So I want to show you this here, instance group. So I was telling, I kind of used inventory to map my instance group. So, but you can also kind of map the instance groups per template as well. So I can actually define instance group here, which instance group. So I can just use private execution nodes here as well. So that's another way of actually mapping the instance group to our automation. Okay, just wanted to show you that. Okay, so this is all good. So everything worked fine. And you saw how actually it got executed on the execution node. Now, I'm going to take one kind of an scenario. So let me go back to the slide to show you that. Okay, let's kind of understand and see how the mesh routes actually work. So I'm going to create a scenario where I'm going to kind of disconnect this connection between the controller 1 to the hop node. So what will happen in that scenario is that because actually this connection goes away, now to execute any of the kind of a job, it needs to go via the controller 2, hop node, and the execution node. Okay, so we will see that how automation mesh quickly kind of reroutes this and then executes in the execution node via the controller 2. So let's see this scenario. So to do that, what I'm going to do is, let me make it big. So I'm going to go to the hop node. So I'm from the hop node, I'm just going to kind of, okay. So what I have done here is that I have added a firewall rule. So I'm just saying that, okay, reject anything coming from 241. So basically this 241 is my controller 1. Okay, so that's basically my IP address of my controller 1. So this, okay. So I'm just saying that, okay, anything coming from 241, just reject it. And I just kind of reloaded my receptors here. So now if I look at my automation mesh status from the hop node. So if I see this, so you can actually kind of, so let's look at from the controller first and then go to this one. So from my controller 1, because actually the connection to the hop node is actually lost, the route will change. Okay, so now if you see this, the route for the hop node 1, sorry, execution node 1 is via controller 2. Earlier it was via hop node because it had that connection. Now in the connection as well, so there's actually only one direct connection, that is to controller 2. So automation mesh automatically learns this. Okay, if something happens, the connectivity kind of is lost, then it knows actually what has happened, and then it kind of understands how to read out things. So here in this scenario, it is going to read out via controller 2 in this scenario. Similarly, I think we can, even from the hop node as well, we can actually view it, right? So here, my controller, to reach my controller 1 from the hop node, it is going to go via the controller 2. So the reverse part of it, right? So hop node knows that to reach this, it is going to take the controller 2 path. Okay, that's one part of it. And I can also show you one more. Okay, so if I just go to the net strat, actually, you can see this. This hop node is connected to the controller. And of course, the hop node is also connected to my execution node. Okay, so this actually shows you the port number as well. So in my inventory, I set it as default. So it's using the 27199 as my the receptor port. So you can see this here. Similarly, here, if I go and so I just have one connection, right? So I have to controller 1 to controller 2. Okay, so just showing you this. Okay, so now we have actually kind of created the scenario where the connection disrupted. Now let's go back and run this execution and see if automation controller 1 is able to kind of execute the job. So let's go back here. So I'm going to kind of launch this again. So the same one. So let me put this side by side. So this 241, basically I'm running it from controller 1, right? But once I run it from the controller 1, it now again still runs it without any issues because it's actually routing via the controller 2 and the hop node, and it executed. So it executed quickly because I think the installation already happened. So it was actually quick. So as we see here, so the automation mesh can actually kind of use this redundant mesh connection to reroute for us. This actually provides better resiliency, right? In a case where we have many kind of execution environments. So this helps us actually to get the job done without any issues, right? Giving you more reliability. Okay, so let's go back. So there's one thing I wanted to show you. Okay, the next thing I wanted to show you is that how it can actually work along with actually having the container groups. So in my environment, I also have a KX cluster and which is connected to SVM. So basically, I'll try and show you how this works. The container group works as well. Of course, this can be our OCP. So I do have a OCP instance. If you're interested, I can show that as well. So let me jump back. Okay, so now if I go back to my instance group, so in the instance group, there are like container groups. There's a standard standard instance group, and there is also a container group. So container groups are for specifically for like using Kubernetes or OpenShift environment. So in my case, I already have one, which is the container group here. Okay, so basically it actually has a credential to connect to the KX environment, and it also kind of uses a pod spec, which actually will be used to create the pods in the Kubernetes actually environment. Okay, so this is our pod spec. So okay, good. So I've actually once I've defined my container group. So if I go to my inventory, so I do have an inventory here. So for this local DC inventory, so this local DC inventory has the instance group of this AX container group. So it's a very similar way we kind of map it. So in this scenario, this particular inventory, DC inventory, is going to use the container groups to execute the jobs. Okay, so let's go to a template. So let's look at so in my case, I have one called web servers for the local DC. Okay, so this is mapped to our local DC inventory. So this local DC inventory is in turn mapped to the container group, VK containers. Okay, so let's try to launch this. Okay, let's put this thing. To view this, let's now, instead of looking at the EE node, so let's look at my KX environment. So this is my KX environment. Okay, so here I'm gonna kind of run. Okay, so watch kubectl get pods and minus and AWX. Okay, so one thing is that in the container groups, you can define a specific actually namespace or a project where all these jobs can run. So in my case, actually, I've defined that as AWX as my namespace. So that's why I'm gonna kind of see it in the namespace AWX. So if I look at it, so right now there is no pods or nothing is running actually on my namespace AWX. Now, when I kind of run this template, okay. So you can see this, there is an automation job which got created and it's actually running. Okay, completed. So then the pod got removed, right? And as you see, actually it completed here and you can see the logs from here as well. Okay, so I can actually do both my automation mesh, actually the execution nodes, as well as I can also use the KX environment, right? This can be like connecting to any KX environment. Like it can be, as I mentioned, it can be OCP or it can be EKS or any other environment. So in my case scenario, I also have, if I go to my instance group, let me show you this. So I have a OCP container group as well. So the kind of configuration remains the same, like between Kubernetes and OCP. So I have a credentials and I have a pod spec for it. And I can just kind of execute on my OCP environment as well. Okay. Okay, so that's showing you how we can actually run on the using container groups. Okay, from a demo, I think that's all I wanted to show you. Now, the example demo topology which I actually used was simple, and it was intentional, right? Intentionally kept that way because to explain the concepts, right? I wanted to keep it that way. But in a real life scenarios, right, you might have different kind of topologies to support, right? So here, I'm going to look at kind of some common deployment design patterns. Okay, so we will just see how some of the common deployment patterns can be achieved in using automation mesh. So let's look at it. Okay, so before I kind of move in here, let me stop here. Any specific question? I know you guys are having some chat, but just stopping here for any live questions you guys might have on the demo.
Yeah,
Or...
feel free to just drop any questions, right? I mean, Vinod, myself, and Derek, we are here. We can help to answer the questions. Or is there any other things that you guys might be wanting to look at? Right, beyond whatever that Vinod has been showing? Just feel free to speak up. We can always arrange for new content and all those stuff in the next meetup.
Yeah.
Okay, I think no questions there. You can move on first. Yeah, thanks.
Okay. So,
sorry. Mohan, you have a question?
Yeah, is the session is recorded session can be shared as well as the PPT can be shared, just for learning purpose, future.
So the recording will be pasted in the YouTube channel.
Oh, okay.
So do subscribe to that. I mean, and do share it, of course, right? Share, like, and subscribe. So yeah,
we will also put it in the meetup page as well. So do keep a lookout. After the session, we will post a recording. If you have any feedbacks, just leave the message over there as well.
Yeah, thank you guys. Yeah.
Yeah, thanks.
Thank you.
Yeah.
Okay, thanks. Okay, so let's look at the first design pattern. So basically, this design pattern is for a demo or a trial kind of a scenario, or where minimal setup is required, right, because of resource constraints. So in this kind of scenario, we will use control nodes to be hybrid nodes itself, right? So you will not have a separate execution nodes. So this is just a starter setup. This is a bare minimal setup which we can have. So we can have one single controller with a DB, which the controller itself is a hybrid node, so it can actually run the execution. So no separate execution nodes. Very simple. It's like a single all-in-one. So it can actually, the controller acts as a controller plus the execution node. So this is a simple thing for like kind of learning, for demos and things like that. If you want to kind of use, you can use this. Then we can also have a starter plus plus kind of a setup. So in this scenario, we will have more than one controller, okay, and with actually external DB, and all these controller will be hybrid nodes. So basically no separate execution nodes, similar to the earlier one, but it's just that we have many kind of controller nodes, hybrid nodes in this scenario. So that's another way we can actually start with for this design pattern one. Now, that's just for this like simple setup, right? Now, the second design pattern I'm going to talk about is for scenarios where we need clear separation of functions, right? And where we are looking at high availability and future scalability point of view. So if you want to set it up in a production where you want to have those kind of things, then you have to look at something like this. So here, we are going to kind of separate the functions, the control plane and execution function. So control plane nodes are going to be only as of type control. That means it only runs control function, and we will have execution nodes. So this shows one example. So we have a controller, again, acting as just a control node. And then I have one execution node, which is actually sitting in my local LAN or my local DC, and which executes all my kind of automation. And then I also have another kind of automation execution node, which is sitting in my DMZ. This execution node is reached only via the hop node here. Okay, so this hop node actually is not going to execute any content, but it's going to route the traffic from their controller to this execution node. So that's, we can actually have it. So local LAN and the DMZ part, you can actually kind of create it. Okay, so I can also have like more than one execution node, right? So in this scenario, I just have a local site and I have more number of devices or the endpoints to kind of automate. So I can have more than one execution nodes. So I can, here in this scenario, I have two execution nodes connected to my control plane. controller, right? So using the automation mesh. So what happens in this case is that the controller actually schedules the job. So it actually finds whichever has the least actually kind of or like more capacity. So basically it kind of pushes it there. So I just wanted to quickly show you that in the instance group, if you've not noticed it, I'm just going to show you this. So there is a status and it shows healthy. So one thing actually the controller does is it keeps actually checking the health of these execution nodes. So making sure that like if something actually happens to the execution node, it doesn't actually pass that kind of job to that node, right? So it checks the health status. So you can see this actually last health check was checked at 10:21 a.m. And then you can actually also see this capacity, used capacity, and then the capacity adjustments. I can actually also adjust the capacity over here. So if I have many nodes, then I can actually, it shows me all the nodes for this instance group, all these execution nodes here, and then it actually has show you the capacity as well. And you can also enable and disable this. So that means that, like, for example, if you are taking that particular execution node out of the mesh, if you want to take it out for certain maintenance and other activities, you can still do it. Like you can just disable this. So that means controller will not pass the job to this particular execution node. Okay, so that's something actually you can do it from the controller. Okay, so that's one part, right? Now we get into more complex kind of scenarios, right? So where we have multiple DCs, multiple zone segregated networks where resiliency is important, then we kind of look at this kind of setup. So here I have a control plane. So where I have 3 controllers acting as my control function. And then it's connected to my DC1 and DC2. So it's actually connected via my whatever available networks, and it can actually have via your firewalls and everything. And then it's connected to execution nodes here. Okay, so basically it's a flat. Basically it means that there is no hop node, but it can still reach these execution nodes, but via your WAN and stuff like that. Okay, so that's one possibility. Then the other possibility is to kind of have like a segregated network, right? So in this scenario that the DC, I have a hop node, which is connected to my execution nodes, which is in the trusted zone. So, and these execution nodes will actually execute my automation in this particular trusted zone environment, like kind of a VPC, if you can think of it, right? So this can also be done. Okay. Now let's take one more kind of a complex scenario. So as I mentioned earlier, right, the mesh actually supports multi-hops. So here, if you look at it, so here I have my control plane connected to kind of set of hop nodes, okay, not one node. And this hop, via this hop node, I can actually go and configure my DC1 and DC2, where I have different sets of execution nodes on it. But I can also have another hop node, okay, which is connected to this hop node. So it's like kind of daisy chains, right? So I have hop node connected to another hop node, which is actually then connected to my execution environment here in my cloud. So just an example, right? So it's connected to it. So we can actually have such kind of a setup. So it actually daisy chains. So as you see here, right, I just talked about some common design patterns. Obviously, in your environment or for your customers, it might be probably different kind of setup you might need. But one thing to kind of actually note here is that automation mesh can help you to kind of address different kind of topologies you might have. Like as you see that there are different types of actually design patterns I showed you, right? And it can actually support it. So similarly, you can actually support your one environment, one topology, whichever you would kind of have it. Okay, so I think we are at the top of the hour. So that's something is what I wanted to show you for today. Okay, I'll stop over here. And if you have any specific questions, we can actually go through.
Hey, thanks, Vinod. I think overall, very good stuff from all the demo use cases and all that. I think it's a very nice session today that we have, right, for automation mesh. I'm mindful of time as well. All right. We will still stay on a while to answer your questions if you have. But if there are none, then would like to thank the rest for joining. And if you have any suggestions for the next
I think
meetup,
there's a question,
let us
right,
know.
Derek?
Oh, yeah.
I think
From
That's a question.
so. This thing around the control plane, they are virtual machines over here, right? So one controller is one VM. So that is what's going on, and that what you saw, we have Podman running, right? So it will be the one running the containers when we run the playbook. Okay.
anybody have any other questions? Or any other questions that you may
Actually, we are
have?
probably more interested
for
in whether you have
clinicians,
any topics in mind that you will want us to talk about next session. Then we can prepare something for next time.
Yeah. I think there was one, question earlier related to private automation hubs. I just want to quickly show it because we are in the demo environment. So in my environment, as I showed you, I also have private automation hub setup. So let me open this as well. Okay. So if you look at my execution environments, so I kind of actually get it from my automation hub. So here you can see this hub one. So my execution environments, I can fetch it from the hub itself, private automation hub. So for example, in my case, I also have another private execution environment, which I just created for Azure automation. So Azure execution environment is actually, I kind of host that in the private automation hub, and I fetch that from that hub to my controller. So you can actually do that as well. I'm just quickly showing it because I think there was some discussion about the private automation hub in the previous meetups. We can go in details and then show you how we set it up, etc. If you're interested in the later meetups as well.
Correct. So basically, what we are showing here is that you don't necessarily have to connect to the internet, right? In order for you to use all these features. Right now, what VNOV has is a on-prem private automation hub where we are able to place the execution environment image inside, and then we can just use it, right? So I think those are things that we kind of spoke about, and people were asking, right? I guess we are good. If
Yep.
there is no other questions.
Okay.
Okay.
So,
Hey, thanks a lot,
yeah.
guys.
Thank you.
Derek,
Thank you, everybody, for joining. And stay safe and have a good week ahead.
Hey, thank you. Thank you, everyone.
Yeah,
Right,
take care,
thanks.
guys.
Have a good long
Take care.
weekend.
Bye-bye.
Bye.
Stop. Oh, until you can stop the recording.
Hang up over here.
Okay.
Thanks, Rahul. Thank you.
Okay.